Good afternoon, all. Sridhar sir, actually we have 66 to 266 registrations. Can I wait for 5 more minutes?
Okay, fine, Arvind.
It's okay.
Arvind, my voice is clear, no? Audible, right?
Yeah, it's audible. It's audible. It's clear. Good afternoon, everyone. Thank you for joining us for today's webinar. I am Alvin Varghese, Assistant Professor of Civil Department, Jyoti Engineering College. I welcome you all to the webinar on Basic Structural Design hosted by us in association with Indian Concrete Institute, that's ICI. Now I would like to introduce today's presenter, Mr. Sridhar Ravindran, structural designer and owner of Closter Designs, one of the leading structural designer in Kerala. He is graduated from TKM College Kollam and postgraduated from Anna University Chennai. He has been working as a structural engineer since 2013. If you have any questions during presentations, please type them in the comment box and we'll clarify. It is in the question and answer section at the end. All of them requested to mute your audio for getting more voice clarity. Thank you. And then once again, welcome you all. And Sridhar sir, now you can start the session.
Hi. Actually, can you, everybody, you can hear me now? Alvin, voice is okay, right?
Yeah, it's okay. It's okay. It's clear.
Okay, good afternoon, everybody. My name is Sridhar. I did my BTech Civil Engineering from TKM Engineering College. Then I did my MTech from Anna University Chennai. Then I was working in Abu Dhabi as a structural engineer. Then I started my own company in Kerala. My office is in Calicut and Kannur. So I hope everybody is safe and fine. Let us hope everything will be back to normal soon. So thank you, Jyoti Engineering College, for inviting me for this one. Thank you. Thank you, Alvin, everyone who is coordinating.
Okay. Okay, sir, you can start.
Yeah. I'm sure. One second. I hope everybody can see the slide. If any difficulty or something, let me know in message or something. So before the session, I'll just tell you a few points. Try to view it in full screen. Better join in laptop or something, or it will be better visual experience. Then if any problem in audio or video, please try reconnecting. It will be okay, fine. Try to view it in horizontal mode, better. So today in this session, I'll be covering four topics mainly. One is our general educational system, that is a small topic. Second is construction sequence, that is also a small topic. Then we'll cover design analysis basics. That is actually an important topic in your career. Then we will cover design with software with small example. That will be also an important topic for you. Those who are opting MTech structural engineering and all, that will be most important thing, this design with softwares. After that, we'll be having a small question answer session. So we all know our general educational system, that is actually, we have many branches in engineering. So in these branches, we'll be having the civil engineering and architecture I'll be mostly dealing with. That is the two branches which is related to structural design. Try to mute everybody, please. So in this civil engineering, there are many options to take masters. So few options are structural engineering, geotechnical, construction management, transportation, environmental, water resources, etc. In this particular list, I'll be focusing on main three. One is structural engineering, which deals with the design of the building elements to make it safe and economical. See, the term economical must be very important. It must not be only safe, it must be economical also. And geotechnical engineering, that is a department who gives us the properties of the soil for our foundation designs. Then comes the construction management, who coordinates and manage the construction at the site. So in our regular construction, these three people have more importance. Other fields are also important, but not in our small house construction and building construction. Now I'll discuss a typical construction sequence. Firstly, one client will be there with small requirement, maybe constructing a building or residence. One client will be there. So 10 years before, this client used to go directly to the contractor and tell his requirements. I need a building like this, or I need a house like this. And the contractor himself will make the plan, architectural plan, and structural drawings, everything, and he only will execute in the site. This was the scenario happening. But now this changed a little bit. Client will go directly to consultants. Now the scenario is changed like this. I think 50% is changed like this. Client will directly go to consultants. Consultants includes architect, MEP engineers, structural engineers, and many other engineers also. Construction management teams also will be there. So the client will tell his requirements to architect. Architect will study what all inputs he can get from the client and what all is the requirement from the client. Then he may prepare a plan, a preliminary plan, in order to satisfy the client. That means in order to satisfy the requirement of the client. So after making a preliminary drawing, preliminary plan, he will again discuss to client, and client will, one second, and maybe plan will be something like small rooms or something, bedrooms, how many bedrooms will be there, that and all, it will be in client's mind. So architect will make a plan accordingly, and he will discuss with the client further. Then this plan will be finalized. After getting finalized, architect will give this drawing to structural engineers and MEP engineers for coordination. Then structural engineers will do the study further. That means he must visit the site and he must check the soil, and then only he can finalize what type of foundation it should be there in that site. Maybe pile foundation must be needed, maybe isolated foundation or raft foundation, depends upon the soil, purely depends upon the soil and the site scenarios. So then same MEP engineers, MEP means mechanical, electrical, plumbing. This term also, it must be in your mind. So MEP will be dealing with actually pipe fitting, and so electrical, plumbing and mechanical will be dealt with this MEP engineers. Then structural engineers will be doing design for the structural members, including foundation, beam, column, slab, etc. So after getting the plan, this structural engineer may have some comments. Sometimes architect needs a big hall without any columns. Maybe it will not be structurally stable. So structural engineer may recommend a column somewhere like this, depends upon the span or something. Then architect may revise his architectural drawing accordingly. And then he may again discuss with the client for a confirmation, because a client may disagree because he first see this plan without the columns. So purely depends on the communications. Then if it is further, client is telling, no, we need a building without a column inside. So clearance will be maybe 10 meter or something. We need to do some other things. That means PT slab or something we need to go. So that also, it is possible, but purely depends upon the client requirement and the budget of the project. Now, after getting all the drawings, these three people will make their drawings and will give to contractor, builder or developer. These people will execute this drawing to the site. This is a typical construction sequence going on in the construction industry. Now, that was our small topic, just to give awareness of the construction sequence. Now, we will go to our major topic. That is, what is analysis and what is design? You may hear these terms regularly. If you are studying and if you are working also, these two terms are regularly you are hearing. But some people may be having some confusion regarding these terms. What is analysis and what is design? I am taking a body. I'm just having. I'll be starting from basics. So even first year student can understand this concept. So I am having one body, and I am giving a certain loading. So when it reaches, the load was gradually increased. When it reaches a certain limit, the body breaks or fails. Now, we have a body like this. Our aim is to analyze the body. Analyze means to find out how much load it will take before failure. That is known as analysis. Now, we have a body like this. We have a width of 40 centimeter and depth of 40 centimeter. For time being, I am not considering the length because I'm just considering 2D for your So we are giving the loading gradually. We will be loading all objects gradually only. So we are increasing the load. You can see at 5 kilonewton, the body fails. That means the body is having a capacity of taking 5 kilonewton load. So that is what is analysis. So in analysis, we found out how much load it can take without failure. Now, we will be, so this body has a result of capacity is 5 kilonewton. Now, we will discuss about design. What is the difference between design and analysis? See, we have a load of 10 kilonewton. Previously, we had a body only. We started loading and we found out how much load it can take. Now, what we are doing is, we have a load 10 kilonewton. We need to design a body to take the given load. Now we have certain calculations. Then we found out, as per the calculation, that 40 cross 80 body is suitable to take 10 kilonewton load. Now what will happen? We'll try giving the loading. See, we started increasing the load. Now it is safe. So we gave a load up to 10 kilonewton and we saw that the body is safe and the body is stable. That means it was designed to take 10 kilonewton. It is not breaking at 10 kilonewton, right? Because we will be having a factor of safety, maybe 1.5 into load, or maybe it depends upon the chords, we will be having a factor of safety. Now, further, we are increasing the load. So, we increase the load and found out that at 12 kilonewton, the body breaks. That means the body can only take 10 kilonewton safely. That is what we can understand from this experiment. So the body was designed for 10 kilonewton, and but still it was broke at the 12 kilonewton. That means there was a factor of safety, that is 12 divided by 10. So that was the factor of safety considered by the designer. Now, again, I have a wall here. This wall, I started loading gradually. So when it reaches a certain limit, it should break, right? So at 100 kilonewton, the wall collapsed. Wall failed. That means the ultimate capacity of the wall was 100 kilonewton. Beyond that, it will not take. Now, what is this capacity and the action and all? See, whenever we are having a force or action, there will be a reaction. When we are giving a force like this, we will get back a force like this. If we are not getting back equal and opposite reaction, the body will fail. That is the failure. Now, when we are giving a load like this, we will be getting back a load like this. So gradually, what happens is, when we increase the load, this load also will increase. So when it happens to reach, like when this is not increasing accordingly, the body will break. This is known as, actually this is just a Newton's third law. For every action there is an equal and opposite reaction. So that is known as equilibrium. Now, if we, in the left side we have a loading and it is increasing, but we are not getting a equal and opposite, it is an opposite reaction, but we are not getting an equal and opposite reaction. That means it is not in this is not in equilibrium. So this is less and this is more. So we have already studied sigma h is equal to 0 is our equilibrium equation. So this equation is not applicable here. See, actually it is not 0. So we are getting an external force, but this is not in equilibrium. So it fails. Now, so these are the three formulas we studied in our first year. So these formulas will be used until you are in service. Actually, while you are designing the building, you need to consider these forces to solve the structural design. Now, so sigma h will be there, sigma v is equal to there, sigma m also will be there. Now, we have a seesaw like this. So one person is sitting like this and one person here. So this is an equilibrium condition. And this 50 kilogram is equal to 50 kilogram. So that is why it is in equilibrium. If this person is having 100 kilogram, then this will not be in equilibrium. Or else this dimension should be different to make it in equilibrium. So this is what we are doing as a structural engineer to balance a force. We will be having many complicated buildings, having maybe one column will be there and one cantilever will be there without counter. So maybe we may need to add additional load upon that to overcome the load here, to make it in equilibrium. This is a simple thing, but this is what we are using in the design. Any software or anything, the same is used. Now, see, for the same example, while we give 10 kilonewton, we are getting back 20. See, when we are giving 30, we are getting 30. So it happens in the, actually this will not be seen by us, but this is an internal reaction which wall gives back while we apply a force. But when it reaches the capacity of the wall, actually we found out the capacity was 100 kilonewton. We already found out in the previous demonstration. So when it reaches 100 kilonewton, further the wall cannot give a reaction to the from the wall. So this becomes 110 and this remains 100. That is why the failure occurs. This is the simple thing which you must understand in order to design a building. Not only building, even in any branch, mechanical also, when we are designing the machines, the same thing will be considered. This was the failure reason. We had a load of 110 kilonewton and that is greater than 100 kilonewton, so it failed. This is the same scenario. This is not in equilibrium actually. Now, this all happens because force is there, right? Whenever we are getting a force, we will be getting a reaction. So there is an action and a reaction. So force means what? Usually in buildings, force means loading. Simply we will consider one beam. One person is standing here. So the body weight of this particular person will be acting on the beam. This is the force and this is the loading. Now we'll discuss what all types of forces and loading. See, we have a body here. This is an unloaded body. This body is having no external force. If there is no external force, there will not be a reaction. Now, another body. We are applying a tension in the body. So while we apply a tension, the body will be having a compression inside. So that is why we told, in order to make it in equilibrium, an opposite reaction will be there. So in this scenario, this is the case. So this is tension force. Whenever we are stretching something, that is known as tension. The terms I am using is very, very important in the design. Now, what is compression? Compression means whenever we are compressing a material, an object, this is known as compression. So these two terms are very, very important, tension and compression. Now about shear. Shear means, as you can see in this graphics, this is shear, sliding. This one I'll explain once more with another video. Now, this is bending. Bending means whenever a body is bending means like this. Now, what is torsion? This is actually when one force is like acting like this and one is acting like this. So this will make a torsion effect in the body. Now, why we study this much of loading? See, when we get a tension load, what we must do? After getting a tension load, we must design a body in order to take this much tension load. If we are getting a 10 kilonewton tension, we must design a body in order to take maybe 10 into 1.5, that is factor of safety. So we will design the body accordingly and that body will take that tension. Now, what about compression? Same thing, we will be having a 10 kilonewton compression and we will be multiplying it by factor of safety and we will be designing that load in order to get a material or an object to withstand that particular compression. Same for shear and bending, torsion. Now, see, it is difficult to get a body with only tension force. There are bodies, but still it is very difficult. Maybe it is it was very few to get a body with only tension or with only compression. There will be a combined effect. That means tension will be there, compression will be there, shear will be there, bending will be there, torsion will be there. So actually these all loads all together will be affecting for a body. Now, this this one will be a combined effect. So this combined effect we need to design. So that body must be designed for tension, compression, shear, bending, torsion, etc. Whatever loading it is having, we need to design for that. That is why for a beam design, maybe you will be doing the beam designs in third year or fourth year. So while doing any column design, beam design, retaining wall design, we will be checking for each case. You will be checking for shear checking, compression, tension, torsion, like that. So this is the scenario and this is the basics of design. Now, by seeing this image, what you can understand? You may tell that, oh, A is very, very strong and B is very weak, right? But actually, this scenario is different. See, A is strong in weightlifting, but he's poor at running. Maybe after running 5 kilometers, he'll be very, very tired and he need a rest. So he can only run up to 5 kilometers. His capacity for running is very low, but his capacity for weightlifting is more. Now, what about this person? He's weak in weightlifting. He can only take up to maybe 10 kilogram or 20 kilogram, maybe. But he can run up to 50 kilometers without resting. So that means what we must understand is, see, this and all we must relate it to our structural design. Here, we can understand that all bodies will be different and unique. All material will be different and unique. So some body will be taking some type of loading more and some type of loading less. Maybe as we already discussed, we have tension, compression, shear, torsion, etc. So these loadings, actually A can take only compression or B can only take tension. So that can happen. So every material or every object is not same. That is what I wanted to tell you. Now, how it relates to our structural engineering. See, we already discussed, we have tension, compression, shear, bending, torsion. So some bodies will be taking tension more. It can take maybe up to 100 kilonewton tension it will take. But same 100 kilonewton, if you give compression, it will fail. Excuse me. So the same body will be taking shear more and not bending, and it may be taking torsion more. So this purely depends upon the material. Now, so I will show you one example of this type of loading, so you will understand more. Some materials are there. Maybe it will take a less amount of tension and high amount of compression and all. I will discuss with you later in later slide. See, some objects will take all the loads. Now, these two forces are most important for you: tension and compression. What is tension and compression? This diagram should be in your mind when you study or doing analysis. Tension and compression. See, in olden days, you can see mud houses. You maybe before 20 years, mud houses was very common. 20-30 years. Now it was replaced, and now it is obsolete now. So previously, this mud structures was there, right? Mud is a material. Mud is a material, but mud has some problems, some weakness. Mud will take compression more. Mud will take compression more. If I have a mud block, if I am giving compression, it will take. But if I give tension, mud will break. And you can see some bamboos here or some wooden materials here in this. So why they adding this type of wooden things? To get a composite material. See, actually, as I told you, we will be having a combination of forces. Tension will be there, compression will be there, shear will be there, torsion will be there. So in order to take tension, we need a material. We need a material in order to take the loading. So we will combine a material which is good at tension with this one. This is a composite material. Composite. So it will act in a combined way. Now, see, I told you mud is weak in tension. You will be thinking why it is weak in tension. You may not be observed. See, if we have a mud block like this, you can see if we stand here, what will happen? This will break, right? This will be happening like this. That is why landsliding occurs. Nowadays, you are familiar with landsliding because, this 2-3 years, we are hearing this landsliding. Why? Because, see, you see this one. You can see this one. When a tension, this is a tension force. When we are having a tension force, the mud fails. That is why we are getting that mud is breaking. I hope you understood this. So this is the scenario in the mud. So I think this now you understood why mud is weak in tension. See, whenever you are seeing some object, you can observe that object and you can analyze that in mind. So that will be clear for you. That is why we use a combined form, that is bamboo plus mud. See, some people may ask, why can't you use bamboo only? You can use, no issues, but see, some other problems will be there, acoustic problem and all. So that must be covered along with the soil. And you can see some grass is inside this one. That is also a combined effect. This grass and all will have a tension force. That is, sorry, it can take tension, tensile. So that is also we are using. You can see here, dried grass. Now, why this is related to our construction industry? See, construction materials, previously it was mud and bamboo. This was the major construction material used previously, before 20 years. Now, this one I already discussed you, mud will take compression more, bamboo will take tension more. See, now it is replaced. Now, mud is replaced with concrete, RCC, and steel, our bamboo is replaced with steel rebars. So, this compression and tension works as the same. For concrete, you all know, it will take more compression, and steel, it will take more tension. See, everybody will be having a confusion. See, whenever we are telling, we will tell concrete is good at compression and steel is good at tension. So that means concrete is weak in tension, right? Concrete cannot take that much of tension. We are neglecting the tension force, which can be tension capacity, right? While you are designing, you will be checking this one tension, but you will neglect it. But steel, steel will take tension more, and people will answer compression, it will take less. No, steel will take both loads. That is why you can see steel structures, that is, you can see buildings only with steel, that is I section, I beams and all, you can see buildings. So, but you can't see a building only with concrete without a reinforcement. Only with concrete you can't see, because tension will be difficult to attain. Now, regarding this, as we discussed, when we are discussing about concrete, we must consider the compressive strength, right? Because concrete is for construction, for taking compressive strength. So that is why we are mentioning M20, M25, like that. So this 25 means the compressive strength of the particular mix. We can increase it. IS code is telling for RCC structure. Maybe this will be asking for PSC exam and all. So IS code is telling M20 we must use. Previously it was M50. Now they changed to M20. We must use M20 for RCC, structural elements, not for PCC. Now, what about steel? Steel, we are considering tensile strength. So this FE 500, 550 and all represents the yield strength or tensile strength. I hope you all are doing this in lab. Now, what is RCC? See, RCC means, don't mistake, it is not reinforced concrete cement, it is reinforced cement concrete. What is RCC? It is a mixture, right? Coarse aggregate will be the important mixture, that is more in this mix. And again, we will be adding fine aggregate, then cement. Then we will be adding water. Then if needed only, we will be adding admixtures if needed. So while going to site, you may see that people are telling what type of mix? Okay, M20. M20 means 1:2, 1.5:3. So what this means? 1 means cement, and 1:5 means fine aggregate, and 3 means coarse aggregate. This is the ratio, and this purely depends upon the design mix. So we have actually site mix also will be there. Maybe the aggregates available in different site will be different. So the best practice is, whenever you are doing construction, just make a cube having IS specification 150, 150, 150 and break it at 28 days and confirm the loading, that is M20 or M25, whatever that is mentioned in the structural drawings, you must confirm it. If you are going for a QC engineer and all, you must know this type of things. Now, what is concrete? We already discussed. This is coarse aggregate. As you already discussed, coarse aggregate will be the major component. Then, see, in the gaps, it filled fine aggregate. Then in that gaps, it will be filling cement. Cement is a binding material. So actually when we add water together, it will be acting as a binder material. Now regarding the supports, actually this you are studying in first semester or second semester in mechanics, but this is a very interesting topic, supports. This is also important when you are taking MTech also in structural engineering, or when you are doing PhD also, this type of supports are needed. See, I am taking one small object. Just consider this small object. This small object can move anywhere. Anywhere it can move, because we are not restricting the body. It can move anywhere. Now, whenever we are restricting, see, when one body is there, it can move anywhere. But when you are telling the body not to go here, what happens? Body will be hitting on this one, and a reaction will be this one, right? I'll show you in different color, that will be fine. See, whenever we are getting a force like this, that means the body will try to move, right? So we will be getting back a reaction. So wherever we are restricting, this point must be very clear for you. Wherever we are restricting, reaction will be there. Action and reaction will be there. If there is no restriction, no reaction will be there. For this particular body, no reactions are there because it is free to move. Nobody is forcing it to stop. It is free. I am ignoring friction for time being. See, now the same body I am taking in one tube. What happens? It can move only in X direction, right? So in this one, it can only move Y direction. So where the reaction will be? Which direction will be the reaction? Obviously, it will be here, right? Because the body will try to go outside, but the wall is giving like this. And body will try to go outside, and body will give like this. So we are getting a reaction like this. The direction of the reaction is very, very important. So another body, we are having a X direction movement. In this one, I think now it will be clear for you. Where will be the reaction? Which direction will be the reaction? You know, this direction, nobody is restricting. So no reaction will be there. But when the body try to go outside, the wall will push like this. So that is a reaction. And again, here also, one reaction will be there. So graphically we can show like this. So this is what reaction is. Now, what happens when a body is in a box? It can't move anywhere, right? So we will be getting reaction all around. So this is the case. The body will try to move, but this will be in fixed. Now, same thing, I am just considering a ball or something like this. Now, this one can move in what all direction? It can rotate like this, right? It can rotate clockwise and anti-clockwise. Clockwise and anti-clockwise. And it can move in X direction. And it can move Y direction. So this is the three possible movements in an XY plane. I am not considering 3D for time being because it may be leading confusion. So for time being, I am taking 2D. So we have X, Y, and rotation. These are the three movements or free movements of a body. Now we will discuss what is roller support. I am one by one I am covering your topic also, roller support. See, while you are studying, you will be actually it is familiar. This roller support is familiar. What is roller support? I am considering three rollers here. what happens? We will see by giving a load. See, when I am giving an x direction load or force, anything, it will move, right? Nobody is restricting the movement, right? It is free to move. So that means we are not getting a reaction in this direction. We are not getting a reaction. It is free to move. Now, x direction is allowed. What about y direction? When we have a y direction force, the body can't go outside because it is restricted. One wall is there, right? So we will be having a reaction. So as we previously shown, x direction is okay, fine. Y direction is not possible. Reactions are there, right? Now, y direction restricted. So this is the, and what about rotation? Rotation is possible. It can rotate like this. So rotation also possible. So only restricted thing was y direction. So we will be getting a reaction on the y direction. Rotation allowed. See, what is the example for this roller support? Have you ever thought about that? While you are studying, whenever you are studying and thing, you must consider, or maybe you must check the examples in your see, whenever you are seeing something, you must give an example with your familiar cases. See, for this one, have you seen a bus? This bus is can be an example for roller support, right? See, when I am giving a force like this, whether the bus will go down. See, if the soil is bad, the bus will go down, I am sure. But this, if it is in a road, hard surface road, it will not go down. So, but if we push like this, and if it is in neutral, only it will move, right? It must be in neutral and without a brake, then it will move. That means it is an example for roller support, right? So that is a common example which you can see everywhere for the roller support. Now, see, we need to check what example is there in our structural department, right? Structural engineering. Have you ever seen any example for this one in any cases?
Yes, sir.
Which, where?
In the case of bridges.
Very good, very good, very good. See, in case of bridges, roller supports are there. You can see the image here. Roller supports are commonly located at one end. Please be noted, it will be in one end only. This allows the bridge structure to expand and contract with the temperature changes. The expansion forces could fracture the support at the bank if the bridge is not locked. If it was locked. See, some small movements will be there. Some delta. If you are studying structural engineering, it will be familiar, delta. So some small deformation, some small deflection will be there. That deformation is allowed. Maybe it's small mm, maybe 10 mm or 15 mm. That is allowed. If that is not allowed, or we restricted that, it will cause problems for the bridge. It will cause cracking. That is why we used to give roller support in one end. Now, after this session, what you must do is check your old mechanics textbook. Anywhere, if you check, if you are seeing one, you can see this type of problems. You can see one place it is hinged support and one place it is roller support. Maybe while I was studying, actually I was confused why everywhere it is like this, and teachers are not discussing about this one, because that time first year we will not be aware of this much. That is why they are not discussing this one. Anywhere in the mechanics textbook you can't see a beam like this. If it is like this, then it is difficult to solve. So you will be seeing like this. Whenever you are finding out a bending moment for a simply supported beam, the simply supported beam will be having a roller support in the one end. That is the condition. Now, and what about pinned support? Now, I think this roller support is clear for everybody. Okay, now what is pinned support? It is very simple. Pinned support means we are just avoiding the rollers and we are just resting the pinned support on the beam. Now, can we do the similar experiment? See, we are giving a load in X direction. Whether can it move or what? Can it move? Somebody can answer, huh? No issues. Can it move?
No, sir.
No. So whether reaction is there or reaction will not be there?
Reaction will be there, sir.
Reaction will be there, right?
Yes.
Yes. Why? Because it is restricted. So reaction will be there. It is right. Now, so previously in the roller support, we was not having the X direction movement. We was not having a restriction in X direction. So we was not getting a reaction. Now the scenario is different. That is the main difference between roller support and pinned support. That is very, very simple now. Now, again. So there is a reaction. X direction is restricted. So this is the pinned support. What about Y? Whether we will be getting reaction or what?
Reaction.
There. So reaction will be there. So this previously for a roller support also same reaction was there. This and all what you studied in the mechanics, and if you go through after my session it will be more clear, I hope. Now what about roller? What about this one? Moments are allowed, right? That is, rotation is allowed in both directions. No restrictions are there. Now, what is the example for this one? Just remove the wheels of the car and you will get a wonderful example. Correct, no? Anyway. So, like this. Now, what is a pinned support in original case? See, whenever we are having a beam, something like this, and we are placing one beam like this, simply we are placing. That is why it is known as simply supported, right? Simply we are placing. So we are having a load and the beam will deflect like this, right? You can see here. And cracks are formed here. Here you can see a small delta. So this is what happens in simply supported beam. Now, one more thing I need to explain to you. Why cracks are here? See, whenever we are taking a concrete, that is RCC, reinforced cement concrete, we are adding steel together. That was our that we already discussed in the first 2-3 slides. We will be adding steel together with RCC, not cement concrete. So we will be getting a composite material. Maybe we will be, if you are taking a beam cross section, we will be getting a reinforcement like this. As per IS code, yes, you are correct. As per IS code, 2 bars minimum we must provide at the top also, no issues. Now, see, why we are providing here? Because we will, if we are considering a beam, we will be having a neutral axis, right? Now, we have compression and tension. That is the main things. So, tension will be here and compression will be somewhere here. It purely depends upon the loading, purely depends. Why? Because if I am getting a loading here, it will be different. So don't by heart it, just consider as per your case. So this tension and compression, wherever compression is there, we need concrete. Wherever tension is there, we need steel. In tension phase, concrete will have a small crack. For sure it will be cracking will be there. That is known as cracked concrete. You may be hearing the terms cracked concrete. What is fixed support? Fixed support means whenever we are getting a beam like this and we are just fixing it, nothing is allowed. No movements, no horizontal movements, no vertical movements, no rotation, nothing is allowed. That type of supports is known as fixed support. These are the three main supports in structural engineering. If you know this supports, for sure it will be very, very helpful for you for your any preparation of gate or something, or even in design, this will help you from solving those problems. And any complicated problems will be having this thing. So these are the indications. See, you can see the difference between our simply supported and this one. See, cracks are here also, right? Previously, crack was not here. Previously, if we had a beam, our beam was like this. This gap was there. But here, no gap is there. So this is what a fixed support is like. See the difference. This is very important for you. Just see wherever I clouded crack formation. And what is this one? A fixed support or simply supported? Anybody? Top side, what is this one?
Simply supported, sir.
Very good. Simply supported. And what about this one? Hinged support, huh? What about this one?
Second one is fixed support.
Very good. Very good. Okay, fine. Now we covered most of the basic things. Now we are going to the elements of the structural design, elements of the structural engineering. While we was telling about the master's degree in structural engineering, we was telling this deals with the design of structural elements considering the safety and economical feasibility. Correct, no? So this one is slab. What are the elements? These are the basic elements of structural design. Slab. And what about this one? Column. And what about this one? Foundation. This one is beam. And again, some other things will be there, retaining wall, this one all will be there, but still, for this type of building, these four are the elements considered. Now, how is the loading occurs? When one person is sitting there, standing there, his load will be transferred to from the slab to the beam, from the slab to the beam. And then what happens? From the beam, it will go to the columns, correct? Then from the column, it will go to the foundation. Then from the foundation, it will go to the soil, and again, soil will give back a reaction, right? That is what we studied this much. When we are giving a reaction, there will be a reaction. See, this portion, soil will be giving back a reaction, and if this reaction is lesser than action, there will be a settlement and there will be a foundation collapse. So, these things about the soil, geotechnical engineers will give us a proper idea or a report. I can show you some report which mentions the N value, that is SBC values for the particular site. Okay, now one second. Okay. Now, better try to make your phone horizontal so that you can see the full video. I hope the video is clear for you. Alvin, it is clear, right? Video?
Right now, yeah, right now video is
Yeah. You can see it. Okay.
just a minute.
Okay. Now, as we discussed, you can see the wall here, right? You can see the wall here. We have applied the load. So 40, 60, and what we observed was when it reaches 100 kilonewton, the wall breaks or fails. So that was the capacity of the wall. And we discussed about the action and reaction. Whenever there is an action, there should be a reaction in order to keep the body in equilibrium, and that reaction should be equal and opposite. Now, if the action is 10 kilonewton, the reaction must be equal and opposite to the 10 kilonewton with direction. Now, this is the typical scenario. Now, see, this one also we observed. When we are giving 20 kilonewton, we must get back 20 in opposite direction. Then only this will be in equilibrium. So for this particular wall, we discussed 100 kilonewton was the capacity of the wall. Now, it reached 80. And when it reaches 100, this wall will collapse. Further reaction we will not get from the wall because the capacity was only 100 kilonewton. Now, we already discussed the compression of the object. What is compression? We already demonstrated, but still I want to show you one video also. This is the compression of the sponge. See, while we are compressing the sponge, you can see it is failing actually. It is deforming. This type of deformation must not be there for a particular object. We have a limit. So if that deformation is at a particular limit, maybe 15 mm or 16 mm, that is okay. For this particular case, it is difficult for the sponge to take compression load. Now, we will consider two wooden block like this. This wooden block, I am trying to give compression. So compression it is taking, but tension this is not taking. See, when I am pulling out, this is coming out because this two individual blocks is not taking tension load, but it will take compression load, right? Okay. I show this example because we all know concrete is weak in tension and strong in compression. For this particular scenario, I will show you another demonstration with this cubes where I consider with this cubes as concrete for demonstration purpose only. Now, what is shear? See, shear means when we actually best example for the shear is this one, scissor. While we cutting the paper is exceeding the shear capacity. That is why it is tearing. You can see the beam also here. The beam shear also you can see here. Now, you can see in the first one, shear failure is happened for that particular beam. First one, shear failure was there. If you are doing MTech or PhD or something, you might be observing this one. This is shear failure. And what is bending? If we have a rubber object, see, this is bending. You can bend the object like this. And for this particular object, it is not okay with the bending. It is bending too much when we are bending. In this demonstration, I just want to show you how the beam bends like this. And we discussed the torsion also, right? What is torsion? See, this is torsion. You can see in this video. So this is what torsion is. And while we design an object for torsion load, we used to design it for that. And our deflection or stress, whenever we are having a load, we will be having a stress. this is a stress deformation, the stress formation in the beam for torsion. Now, previously I was telling you that some objects will be having a capacity to take only tension or only compression. See, I have a thread with me. I have a thread with me, and I am just trying to pull it. So pulling means tension, right? Just remembering this one, this is compression and this is tension. So this must be clear for you, tension, which is compression and tension. Now, in this particular string or a thread, when I am pulling, it is taking load. But while I am compressing, it is not at all taking the load. Not at all taking the load. So this object, see, shear also it is taking somewhat. Shear also it is taking. But it is not taking tension, it is not taking compression. It is good at tension. So some properties, some materials are like that. Okay, now, see, in this demonstration, I'll show you one thing. See, while we are bending the beam, I told you that we will get a compression zone and a tension zone. See, this beam has lines upon that. Observe the lines, please. You can see here the lines has stressed too much, right? And here it is less. That means what you can observe is here it is compression, right? And here it is tension. So this is a compression zone and this is a tension zone. Fine. So this is the scenario. You can observe the lines. You can observe the lines carefully. Okay, now we may have a cantilever, right? Sometimes we may get a cantilever. Maybe bending will be in opposite direction. Opposite direction means the same thing, it will be in ulta. That is, compression will be down and tension will be up. So the basic principle is wherever we are getting a tension, we must provide a steel reinforcement because concrete is weak in tension. Now, this is a actually bending stress diagram. When we was analyzing one bending stress, the stress was like this. You can see the red color which is increasing. Okay. So I hope this is clear for you. Now we will continue with our presentation. Just wait 1 minute.
Beam will deflect. See the crack formation and the deflection pattern. But this is how a slab will deflect, simply supported slab. See the non-loaded slab and the loaded slab. This is how a not simply supported, it is a fixed continuous beam. See the deflection pattern and the crack formation. This is a fixed slab and a fixed beam. This is a typical retaining wall which I modeled. We will just discuss the loads used for design. dead load, live load, wind load, and earthquake load. So dead load means a self-weight and permanent loads. It will not move. It is not a temporary load, it is a permanent load. So every object or a material will be having a density rho. And we have 4 IS codes for this one. One is IS 875 part 1, that is for dead loads. And here you can see all loads. It will be per meter cube. You can see lime mortar, lime plaster, common engineering bricks, glazed bricks, etc. From this you will get the raw value and you can just multiply with the volume. So volume into density, we will get the load of that particular object or material. So concrete unit weight is 25 kilonewton per meter cube. Now live load. Live load means it is not a permanent load, it will be temporary load which is upon the slab. We will use IS 875 part 2 imposed loads. So you can see in this one, you can see each specific building there is a different loads. So maybe dining rooms, cafeterias, they are giving 3, then office buildings 2.5, dormitories 2. So this is depending upon the usage of the building, they have categorized. Like that we will calculate the live loads. Now the wind load. So actually wind load act like this for a building. If it is a tall building, then it will be critical for wind. And we will be using IS 875 part 3 wind loads. In that code, they have given a map, categorized map. So we can see which area we are coming in. And then we can calculate the wind pressure using this. Then comes the earthquake load. This will be like this. So for earthquake, we use IS 1893 part 1. In this also, they have categorized India in seismic zones. So we need to check in which area we are coming, in which zone we are coming. Then we will calculate accordingly. Then we will apply that load to our model. Just we will consider one beam. In this beam, when we bend the beam, just notice where the compression and tension comes. In the top portion it is compression and bottom it is tension. So I'll show you another video to demonstrate this one and to understand where we exactly provide the tension reinforcement.
We know that concrete is weak in tension and strong in compression, but steel is strong in both tension and compression. We shall see a video to understand the working principle of RCC, reinforced cement concrete. For simplification, we are taking identical materials which shows similar properties of concrete and steel. In this video, C represents compression and T represents tension. Consider 2 wooden cubes. When we apply a compression force, it does not fail. But when we apply a tension force, it fails or it detaches as shown in the video. So this represents concrete with similar property. Simply by giving a load, we'll make a V shape with opening on the other side of the load application. One side it will be compression and other side it will be tension. This insulation tape can withstand tension as we can see. This represents steel with similar property. By joining these two, we will get a material which can withstand both tension and compression. We need to know where exactly to provide steel. While trying steel at the top, there is no material to withstand tension in the bottom. Hence, it fails. Providing steel at tension phase will make the material to withstand tension and compression. Consider two columns. When we try to keep a beam with reinforcement at the top, it fails when the load is on the top. The same beam will be stable when we provide reinforcement in the tension phase. When we have a cantilever, our tension phase will be at the top, so we need to provide reinforcement at the top of the cantilever.
We have a wall upon one beam. Let this beam be a simply supported beam, and we will try to draw free body diagram. It will be like this. It will be a UDL on the beam. We'll calculate the wall load and we'll be applying this one. And then we need to find out the bending moment diagram and shear force diagram. After finding these two, we can design the beam. We will check with an example. Just consider 4 meter beam having 10 kilonewton per meter load. And we know the bending moment will be WL square by 8 and 10 into 4 square by 8. So it will be bending moment at the center. And shear force W into L by 2, and it will be 20 kilonewton in both sides. Now we will model the same beam in ETAPS, 4 meter. And we will assign the supports to pinned because it is a simply supported beam. Then we will give a loading that was 10 kilonewton per meter wall load. After this, we will analyze. Then we will get the bending moment and shear force diagrams. So we will check the reactions first. We are getting 20-20. So that is W into L by 2. This is bending moment. And we will check the shear force. It is also 20. So that means the manual calculation is matching. So now what we will do is we will try to design it. So we will assign the beam as beam 20-20. That is 20 centimeter depth and 20 centimeter width. We will try to find out the reinforcement required. And for time being, we are ignoring the dead load. We are just taking the live load. So using these values, moments and shear, we'll be designing it. So we got the reinforcement. So you can see at the middle, you are getting 392 and supports, we are not getting negative moments because it is simply supported. This is the report. And this is the shear values and all. Quickly, we'll try to model one building, G+20 building. We have drawn the grids and we'll try to draw the columns. Then I'll draw the beams. I have defined the beams and columns and slabs also. So I'll connect the beams to get the ties. Then I'll take the slabs and I'll draw. Slab is thickness is I have considered 12 centimeter thickness. So this is the building. Now we will start loading. Mainly we'll be having two types of loading now. One is this live load for the slabs and dead loads for the slabs. Then wall load on the beams. We're not giving earthquake and seismic wind load time being. ETA will automatically take the load combinations 1.5 dead load plus 1.5 live load as per IS codes.
Now, that was the design for small buildings. I hope actually we exceeded 3 o'clock. 1 second. Okay, fine. Now, just if you have any queries or doubts or something, you can ask. I think some questions we got in messages. Yeah, you can ask if anything.
Thank you, Srirak sir. Now we are having our question and answer section.
Yeah, sure.
If anybody having any questions, you can put it in the chat box. So I will read out the questions for you. So we have got a question.
Yeah.
In RC frame structure, primary beam to secondary beam connection is considered as fixed or simply supported. Why?
See, actually, I'll show you 1 second. See, when we have a 1 second. Okay, when we have a building like this, his question was: we have a column here, and we have a beam here, and we have a column here, and here we have a beam here, and this beam is a secondary beam. Now, this support actually will be like a simply support because the main beam will have a torsion release. In ETABS also, we have some releases option. So better we can do the release and we can analyze like simply supported. No issues. Hello, is it clear? We can make it simply supported, no issues. Small partial fact, this one was fixity will be there.
Okay, thank you, sir. Any more questions? Thank you, sir. I hope there is no more questions. The feedback link of today's webinar is shared in the chat box. Kindly make sure that you will fill the feedback form within 30 minutes.
So if anything, if any further doubts and all, they can contact me if anything.
Sir, we have one more question. Shall we design Sangan slab in E-tabs?
No, actually there is a possibility problem is there. We can't do like that. Manually we must do.
Okay, sir. If further questions, you can directly contact Sir Vinny's contact number. Thank you, sir. Now we have reached an end to today's webinar. On behalf of Department of Civil Engineering, Jyoti Engineering College, I take this opportunity to thank all those who have contributed to the webinar, Basics of Structural Design, organized by our institute. At the outset, I thank our guest of honor and resource person, Mr. Srirak Ravindran, Structural Engineer, Closter Designs. We are really enlightened with your knowledge and presence and grateful to have you here, sir. We are thankful to Father Roy Joseph Vadakan, Secretary and Campus Head, to our Principal, Dr. Sunny Joseph Kalayatangal, and our HOD, Ms. Vinci Varghese, for their support. I would like to thank our coordinator, Mr. Alvin Varghese, Assistant Professor, Jyoti Engineering College, for his enthusiastic support. Our heartfelt thanks to all the students and teachers for active participation. Thank you.
Thank you. Thank you, everybody.
Thank you, sir. The certificate for the active participants will be provided within 2 weeks.
വരുവാ ലിങ്ക് കൊടുക്കാറുണ്ട് സാറേ, ലിങ്ക് ഒന്ന് കൊടുത്തായിരുന്നു. അങ്ങനെ കേറി പക്ഷെ പെട്ടെന്ന് വേറെ ആരുടെയും കൂടെ പോയാൽ ഇത് അങ്ങ് വിഷമിക്കുവാ എന്നോട്